So last class we discussed about the conditional probability. This class our discussion is confined to independent and dependent events. So as we discussed, conditional probability means P of A by B. If this P of A by B is equals to P of A, or P of B by A is equals to P of B, then we can say A comma B are independent events. Otherwise, A comma B are said to be dependent events. Observe here, P of A by B is equals to P of A, or P of B by A is equal to P of B. Then we say A comma B are independent events. But in case of independent events, what about the multiplication theorem? As you know, P of A intersection B is equals to P of A into P of B by A. Or we discussed P of A intersection B is equals to P of B into P of A by B. But when A comma B are independent events, what happens this one? P of A. In case of independent events, P of B by A is equals to P of B. So P of A intersection B is equals to P of A into P of B. Then we can say A comma B are independent events. Otherwise you can observe here also P of B. In case of independent events, P of A by B is equals to P of A. That is equals to P of A intersection B. So P of A intersection B is equals to P of A into P of B. Then we can say that A comma B are independent event. That means probability of occurrence of A does not depend on B. Probability of occurrence of A, occurrence or non-occurrence of B, occurrence or non-occurrence of B does not affect its probability. That is P of A by B. Mutually exclusive events means A intersection B is equal to 5 and P of A intersection B is equal to 0. Whereas independent events means P of A intersection B is equal to P of A into P of B. Then we say that A comma B are independent events. Right? So P of A intersection B is equal to P of A into P of B, or P of A by B is equal to P of A. P of B by A is equal to P of B. Then we say A comma B are independent events. But now in case of independent events, what about P of A union B? As you know, P of A union B can be written as P of A plus P of B minus P of A intersection B. But in case of independent events, we can write P of A intersection B is equal to P of A into P of B. Now observe here what I am doing. This can be written as 1 minus 1 plus P of A plus P of B minus P of A into P of B. Right? So this we can write it as 1 minus, from these two if you take minus common, we will get 1 minus P of A. Right? Next, from these two we can take P of B common. If you take P of B common, we will get 1 minus P of A. Now here also 1 minus P of A, here also 1 minus P of A. So if you take 1 minus P of A common, 1 minus P of A we are taking common, then we will get 1 minus P of B. So what we can write this one? 1 minus P of A can be written as P of A bar. 1 minus P of B can be written as P of B bar. So in case of independent events, P of A union B, we can write it as 1 minus P of A bar into P of B bar. So just observe here, if A comma B are independent events, A comma B are independent events, then we can say A comma B bar are also independent events. At the same time, A bar comma B are also independent events, and A bar comma B bar are also independent events. If A comma B are independent events, A comma B are independent events, then I can say A comma B bar also independent events, A bar comma B also independent events, A bar comma B bar also independent events. Sir, how can we say that A comma B bar are independent events, or A bar comma B are independent events, A bar B bar independent events? How to say is, first of all, A comma B bar, to show independent events, we have to show A intersection B bar. P of A intersection B bar is equals to, if you show P of A into P of B bar, then we can say A comma B bar are independent events. If A comma B are independent events, I am going to show these two events also independent events. I hope so everyone know about this one. A intersection B bar, we can write it as, come on, A minus B. From A, the part of B we have to exclude. That is nothing but P of A intersection B bar. P of A intersection B bar, we can write it as P of A minus B. Right? So that is nothing but P of A minus P of A intersection B. Right? As we know, A comma B are independent events. In case of independent events, P of A intersection B, we can write it as P of A into P of B. Now if you take P of A common, we will get 1 minus P of B. So 1 minus P of B can be written as P of A into P of B bar. Right? So P of A intersection B bar, we got P of A into P of B bar. So we can say A comma B are independent events. But at the same time, similarly we can prove this one also. As you know, A bar intersection B, we can write it as B minus A. That's why P of A bar intersection B, we can write P of B minus P of A intersection B. So with the help of this, we can prove these two events also independent events. But how can we say that A bar comma B bar are also independent events? To show A bar comma B bar are independent events, A bar comma B bar are independent events, first of all this we can write it as A union B whole bar or not, according to De Morgan's law from set theory. A union B whole bar is equal to A bar intersection B bar. Now I can write this one as 1 minus P of A union B. Right? 1 minus P of A union B. This is equals to 1 minus, just now we discussed, P of A union B is equals to 1 minus P of A bar into P of B bar. Because in case of independent events, P of A union B is equal to 1 minus P of A bar into P of B bar. So 1 cancel, we are getting P of A bar into P of B bar. Okay, so P of A bar intersection B bar, we got P of A bar into P of B bar. Then we can say A bar comma B bar are independent events. So next class we are going to discuss how to do different types of problems based on addition. First one, basic probability. Next, how to do the problems based on conditional probability, and next based on dependent and independent events. We will try to discuss a few questions on probability. Okay, bye bye.